Hello all, and welcome to um, our Chapter 3 video lectures. This is the first one for Section 3.1. You can find a blank copy of these handouts on my Math Lab on the handouts page. So in Chapter 3, we're going to be talking about polynomials and rational functions. Rational functions being a polynomial divided by a polynomial, so that's why they're in the same chapter. So to start out, what we're going to do is we're going to delve a little deeper into some of the things we've already talked about that fall under this category, specifically quadratic functions and inequalities. So quadratic functions are some of the simpler types of polynomials, and we talked quite a bit about these back in Chapter 1, but now we're going to talk more about them under this idea of a function specifically. So anytime you go to graph something, a really easy way to start a problem like this would be to graph it. So if we wanted to start this problem out by opening our class calc app, and sorry, I forgot what the equation was, negative 2 times x plus 3 squared plus 8. So we can graph y equals negative 2 parenthesis x plus 3 squared plus 8. Let me just check and make sure I got that right. Yep. Okay. So now we can use this graph to do a number of different things to talk about the questions they're asking us for. So the first thing you might want to do is get some ordered pairs here and transfer them into your graph on your notes. But let's go ahead and just talk about some of the stuff that's going on here first of all. So from the equation, we can see several things from this graph. First of all, this point up here at the top is called the vertex. And in this case, the vertex is at negative 3, 8. We can also see the x-intercepts, which we've talked about x-intercepts before. It's where the graph hits the x-axis, or at negative 5, 0, and 1, 0. And then down here, we can see that the y-intercept is at 0, negative 10. So those are all good pieces of information to transfer into our notes here. So in our graph, we've got negative 3, 8 is our vertex. And then we've got our x-intercepts at negative 5, 0, and negative 1, 0. And our y-intercept down here at negative 10, 0. Okay, so those are all things we just very easily found from looking at the graph on our graphing calculator. So let's also talk about how we could find them algebraically in case we ever need to. So number one up here at the top is the vertex. So the vertex comes from the form of the equation we're dealing with, which is y equals a times x minus h squared plus k. And in this case, the vertex is h comma k, which for our purposes here are negative 3, 8. So there's our vertex. And that's how you get it from the equation. Number two is the axis of symmetry. So every parabola has an axis of symmetry that is the vertical line that cuts the graph in half. And in the case here, this is going to be x equals h. So for us, that's going to be x equals negative 3. It's x equals the x-coordinate of the vertex. So I can draw in my axis of symmetry here as a dotted dashed line. And so you can notice that every point that's on the right side is mirrored on the left. So we have our two x-intercepts here that got mirrored from each other. So that means my point down here, 0, negative 10, is also going to have a mirror image. So 0, negative 10 is 3 units from the axis of symmetry on the right. So I should have a point 3 units on the left from the axis of symmetry. So I can add that point in. So that's one of the useful things about the axis of symmetry is the graph's going to look the same on both sides. So then next we could do y-intercepts. So we've talked about y-intercepts before. To find the y-intercept, you let x equal 0, and then you solve. So in this case, that would be y equals negative 2 times x plus 3 squared plus 8. So, except we're going to substitute in 0 for x. So this would be y equals negative 2 times 3 squared plus 8. So that's y equals negative 2 times 9 plus 8. So that's y equals negative 18 plus 8, which is negative 10. So we get our y-intercept of 0, negative 10, which is exactly what we found from the graphing calculator. The next thing it asks us for is x-intercepts. So to find x-intercepts, we let y equal 0 and solve for x. So that'll be 0 equals negative 2 times x plus 3 squared plus 8. Subtract 8 from both sides. And we get negative 8 equals negative 2 times x plus 3 squared. Divide both sides by negative 2. And we get 4 equals x plus 3 squared. Take the square root of both sides, and we get plus or minus 2 equals x plus 3. And so that means we've got x plus 3 equals 2, or x plus 3 equals negative 2. Subtract 3 from both sides. And we get x equals negative 1, or x equals negative 5. So our x-intercepts are negative 1, comma 0, and negative 5, comma 0. Once again, exactly what we found when we looked at the graph of this on Class Calc. Number 5 says opening. Opening is simply rather this graph opens up or down. From the graph, we can tell that this opens down. And this is related to that first number, this a. So if a is greater than 0, it opens up. If a is less than 0, then it opens down. In this case, we got that it opened down. Number 6 is the range. So from the graph, we can see that the highest point is at negative 3, 8. So that means the range is going to go from negative infinity to 8. And so in the case, so if it opens up, our range is going to be k to infinity. And in this case, when it opens down, it's going to go from negative infinity to whatever k is. So k was 8. So our graph opened down, so our range goes from negative infinity up to that number, because that's going to be a maximum value, which is what number 7 is about. So in this case, because it opens down, we have a maximum value and point, okay, a max. The maximum point is negative 3, comma 8, and the max value is 8. Okay, and last but not least, the eighth thing, second to last, the eighth thing they ask us for here is to say when the graph is increasing, decreasing, or constant. So in this case, we can see that the graph increases from negative infinity to negative 3, and then decreases after that from 3 to infinity. Negative 3 to infinity. And notice that if this had opened up, these would actually be reversed. So this would be decreasing and this would be increasing. And then number 9 is for us to sketch the graph. So we can take these points we have and the graph that we saw in Class Calc and draw a fairly nice little sketch of what that looks like. So that's the idea. So if this is in this vertex format, that's where all these numbers come from. Now, if it's not in this vertex format, like this next problem here, we can start out exactly the same way. So we take our Class Calc app, so 3x squared minus 12x plus 1. So we take our Class Calc app, and we're going to graph it. So y equals 3x squared minus 12x plus 1. Okay, and from this we can see most of the same things that we saw with the last one. So we've got the y-intercept at 0, 1. We've got our vertex down here at 2, negative 11. And we've got two x-intercepts. But unfortunately, in this example, the y-intercepts, the x-intercepts are not whole numbers. So we're going to need to use the form the equation, we're going to need to solve the equation to find out what those are. So let's go ahead and take these ordered pairs and move them back into our notes. Okay, so we've got 0, 1, 2, negative 11, and then we've got these decimals here. Okay, so 0, 1, we've got these two decimals that fell in here. So one was just a little bit, was 0 point something, and the other one was 3 point something, and then we've got 2, negative 11, which is down here just past the bottom of the graph. And now we can start answering exactly the same questions that we answered on the last one, right? So I can start, the first thing it asked me for is the vertex. So the vertex in this case from the graph, we can tell is 2, negative 11. But if we wanted to find the vertex on our own, using without using the graphing calculator, for an equation that looks like this, ax squared plus bx plus c equals 0, equals y. The vertex is at negative b over 2a, comma, f of negative b over 2a. So in this example, that would be negative 12 over 2 times 3, and f of whatever that is, negative 12 over 2 times 3. So that's 2, and then we plug 2 into the function. So 3 times 2 squared minus 12 times 2 plus 1, which is 2 comma negative 11. Okay, so that's how you find the vertex without the graph. But most of these vertexes you're going to be able to find just using the graphing calculator. The second thing is the axis of symmetry. So as we said before, the axis of symmetry is the vertical line that passes through the vertex and cuts the graph into two pieces that are symmetric to each other. And in this case, that's going to be x equals 2. And in general, it's x equals negative b over 2a. Okay, and also because this is an axis of symmetry, I can mark a symmetric point here. 0, 1 is 2 units to the left of the axis of symmetry. So the point 4, 1 is a symmetric point on the other side. Number 3 is the y-intercept. The nice thing about this for the y-intercept is it's really easy with a equation like this. We already found it from the graph to be 0, 1, but you simply let x equal 0. And in an equation in this format, what happens is everything except the constant term goes away. So that simplifies really easily to just 1. So we get 0, comma 1. Okay, number 4. Like I said, we're going to need to use, we're going to need to solve the equation here. So we let y equal 0. So that's going to be 0 equals 3x squared minus 12x plus 1. And here is one of the reasons why we talked about a bunch of different ways to solve quadratic equations in the previous, in chapter 1. So what we're going to do here is use the quadratic formula. So this is x equals 12 plus or minus the square root of negative 12 squared minus 4 times 1. 3, sorry, times 1. So minus 4 times 3 times 1 all over 2 times 3. So that's x equals 12 plus or minus the square root of 144 minus 12, which is 132 over 6. And then we can look for a perfect square that's a factor of 132. So I think, well, 6, I think, hold on. So we can take out a 4. So this is going to be 2 root 33 over 6. And then we can simplify by dividing each piece by 2. So this is 6 plus or minus root 33 over 3. Okay, and so that means our x-intercepts are 6 minus root 33 over 3 comma 0, and 6 plus root 33 over 3 comma 0. And those match up to those decimals that we found using the graph. Number 5, opening. A here is greater than 0, so it opens up because A equals 3. 6, the range. So the range, remember, goes from the vertex to infinity or in negative infinity to the vertex, depending on if it opens up or down. This one opens up, so that's going to be negative 11 to infinity, which means we have a maximum point at 2 comma 11. This function is going to decrease first because it opens up, so we go down and then back up from negative infinity till we get to the vertex at 2, and then it's going to increase from the vertex at 2 to infinity. And then we can take the points we already have and we can draw a little sketch of what this graph looks like. Okay, so that's all there is to that. So why don't you all go ahead and flip over to the next page. There are 2 more of these. Take a few moments and try those 2 out. Pause the video, try those 2, fill in these points, and then we will, when you restart the video, we'll go through them. Okay, so to start out here, I'll go ahead and start by drawing the graph so I don't have to go over to the class calc app because you guys should have all tried this, but so I did this one on my own. So I get a vertex there at 1, negative 5, a y-intercept at 0, negative 6. So then I get a symmetric point at 2, negative 6, and then I could also find some other points. So another point should be negative 1, negative 9, and 3, negative 9. So we get a graph that looks something like this. And now we can go through and answer these questions. So the vertex is at 1, negative 5. The axis of symmetry, therefore, is at x equals 1. The y-intercept is at 0, negative 6. There are no x-intercepts, right, because it opens down and we're below the x-axis. And to just show you what happens when you try to do this, if I use the quadratic formula here, this is negative 2 plus or minus the square root of 2 squared minus 4 times negative 1 times negative 6 over 2 times negative 1. And if we solve that, we get negative 2 plus or minus 4 minus 24, so I get negative 20, the square root of negative 20, and the square root of negative 20 is going to give me an imaginary number. So that's why I don't get, this would be 4i root 5 over negative 2, which is x equals 1 plus or minus 2i root 5. So I get imaginary roots for that equation, which means that I have no real x-intercepts because all of the x-intercepts are real. So if you try to find x-intercepts and you get imaginary solutions, that just means there are no x-intercepts. 5, this opens down. 6, the range, because it opens down, is from negative infinity up to the vertex, which is at negative 5. The maximum value here is at 1, negative 5 at the vertex. And real quick, let me check something because I'm not sure. One thing I should mention on number 7 here on the previous page is that that's a minimum value because it opens down, which I didn't write. So this one's a max because it opens down. The one on the previous page opens up, so that's a minimum value. And then last, this increases until we get to the vertex from negative infinity until we get to 1, and it decreases then from 1 to infinity. Okay, so that's the idea. And then the other one on the next page, this one has a vertex at negative 1, negative 9. And then we can add in some points here. Its y-intercept is at 0, negative 8. Its x-intercepts are at 2, 0, and negative 4, 0. And so we get a graph that looks something like this. And so because everything comes out of the class calc app, we can do this pretty quickly. The vertex is at negative 1, negative 9. The axis of symmetry is at x equals negative 1. The y-intercept is at 0, negative 8. The x-intercepts are at negative 4, 0, and 2, 0. It opens up. The range, because it opens up, starts at the vertex at negative 9 and goes to infinity. There is a minimum point because it opens up at the vertex. And because it opens up, it decreases first from negative infinity until we get to the vertex, and then it increases from the vertex to infinity. Okay, so that's the idea there. Now, because, so now we can use these graphs to do something that we did in a previous section, which is use graphs to solve inequalities. So when we do these, what we just want to do is we want to look at, we can just graph them with the calculator, and we might need to fill in some of the values using algebra, but we can start by graphing with the calculator and go from there. So for this first example here, let's just graph x squared plus x minus 2. So y equals x squared plus x minus 2. Okay, and so this graph looks like this. And what we're here about is the x-intercepts and then where it is positive and negative. So the x-intercepts here are at negative 2 and at 1. So a graph for this, a quick sketch of it, would look something like this. Right, I've got my parabola that looks like this. And so then here's negative 2 comma 0, and here's 1 comma 0. And so below the x-axis is where we're less than 0. On the x-axis is where we equal 0. And above the x-axis is where we're greater than 0. So in this case, because we're looking for greater than or equal to 0, we're looking for the pieces that fall under those two categories, greater than or equal to 0. So greater than or equal to 0 would be the parts of the graph over here and over here. In the middle, the graph is below the x-axis, so that's less than or equal to 0. So this region over here on the left is negative infinity to negative 2, and the region on the right is 1 to infinity. And then the only questions you have to ask, now that we figured out that it's these outside two pieces, is do we include the endpoints? And because it's or equal to, we do include the endpoints. And then this is going to be the union of those two together. So the solution set for that inequality is the compound equality, negative infinity to negative 2, or 1 to infinity. If you fall into either of those categories, you are part of the solution set. And so that's going to be the idea here, is we're going to graph it. We're going to look for the piece that matches the graph we drew, and then we're going to state the solution set. So if I did the second one here, so that one is x squared minus 2x plus 1. And so in this case, notice that we have our x-intercept, and it doesn't cross the x-axis. So that's at 1 comma 0. So our graph for this one looks something like this. So we just touch the x-axis at 1 comma 0. But the same idea is still true. Less than 0 is below the x-axis, equal to 0 is on it, and greater than 0 is above it. In this case, we're looking for less than 0, so we want to know when is the graph below the x-axis. Well, in this case, is there anywhere that the graph is below the x-axis? The answer is no. So therefore, there are no solutions. So we could write the solution set as the null set or the empty set. So that one has no solutions. Okay, so that's the idea. So let's try a couple more together. So the next one is x squared plus 4x minus 1. Yep. So notice with this one, when I go to get the x-intercepts, notice that I get decimals. So that's not going to be great. We don't really want decimals, but I can still use this graph to figure out what the answer is going to look like. I just need to figure out what those x-intercepts are. So in this case, the graph looks something like this. Okay, but I don't know exactly what these points are. I have decimal approximations, but I don't know exactly what they are. But I can go and do the rest of the problem. I still know that greater than 0 is above the x-axis, equal to 0 is on it, and less than 0 is below it. So in this case, we want to be less than or equal to 0. So less than or equal to 0 is below the x-axis or on it. So the graph is below the x-axis in the middle here, and it's on the x-axis at these 2 points. So our answer is going to look something like this. Bracket, blank, comma, blank. And I just need to fill in those blanks. Well, to fill in those blanks, I just need to know when does x equal 0. So we take this equation, x squared plus 4x minus 1, and we solve it. And we can solve it using the quadratic formula. So this is x equals negative 4 plus or minus the square root of 4 squared minus 4 times 1 times 1 all over 2 times 1. So that ends up being negative 4 plus or minus the square root of 12 over 2, which is negative 4 plus or minus 2 root 3 over 2, which is negative 2 plus or minus root 3 when I cancel out a 2. So those are our 2 endpoints, negative 2 minus root 3 and negative 2 plus root 3. So the minus 1 goes on the left, right, because that's going to be smaller, and the plus 1 goes on the right. Okay, so these go in there. And so that's all there is to that. So if you get the values from the graph, wonderful. That makes it a lot easier because you don't have to worry about solving these. But if you do have to solve them, you can. Just use quadratic formulas. The next one here. One thing you have to do before you can deal with these is set one side equal to 0. So subtract 6t from both sides. So this is 0 is less than or equal to t squared minus 6t plus 25. And if you want to make your life a little bit easier, you might want to flip this whole inequality around so the variables are on the left like all the other ones. So when we do that, you just have to remember to also flip the inequality symbol. So this is t squared minus 6t plus 25 is greater than or equal to 0. So then we can go into our calc app and we can graph that. But remember, you always need to use x when you graph things. So x squared minus 6x plus 25. And if we do that, I'm going to have to zoom out a little, obviously. Look, it's all above the graph. Okay? So the parabola looks something like this. And then my graph is up here. So still, this is greater than 0, equal to 0, and less than 0. So in this case, we want to be greater than or equal to 0. So that's this piece and this piece. And where are we greater than or equal to 0? Well, we're greater than or equal to 0 everywhere because the graph is always above the x-axis. So the solution here is negative infinity to infinity. So if you don't have any graph in a region, it's going to be the empty set. If all of the graph is in the region you're looking for, then the answer is going to be everything. So go ahead and flip over to the next page and try solving these inequalities. Pause the video and go ahead and try these on your own. And then when you're ready to go through them, go ahead and hit play and we'll go through the answers. Okay, so I'm just going to go ahead and graph all of these to start out here so we can get a good idea. So the first one, once you set one side, start with this one. There is one thing you need to do for 3 of these before you do anything else, right? You need to set one side equal to 0. So this would be negative 5x squared plus x plus 6 is greater than or equal to 0. This one down here is 0 is less than x squared minus 7, which is x squared minus 7 is greater than 0. And this one is y squared minus 6y plus 3 equals 0. Okay, so the first graph looks something like this. Okay, so when you get it, this x-intercept is negative 1 comma 0, and this one is 1.2 comma 0. So one thing you definitely want to do is change that into a decimal, into a fraction, which your calculator can do for you, and that's 6/5 comma 0. This graph looks something like this. So we've got negative 1 comma 0 and 3 comma 0. This graph looks something like this. But these two x-intercepts are decimals, so we're going to have to use some algebra there. And then the last one looks something like this. And once again, for this one, we're going to get some decimals, so we're going to have to do some algebra. Okay, so let's go and go through these answers. So this one, we want to be greater than or equal to 0. So in that case, the part that's above the x-axis is this middle part. So the answer here, and it's or equal to, so the answer is going to be negative 1 comma 6/5 with brackets, because we're including our answers because it's or equal to. This one, we also want to be above the x-axis, but those are the outside pieces are above the x-axis. So we're going to get negative infinity to negative 1, parenthesis, union, parenthesis 3 to infinity. So notice I use parentheses because it's not or equal to. This one, we need to solve x squared. Well, actually, before I do that, we can say the answers for this one, since it's greater than 0 as well. The part that's above are these outside pieces, so it's going to be negative infinity, comma, blank. We're going to use parentheses because it's not or equal to. And now we just need to fill in those blanks. So we do x squared minus 7 equals 0. Add 7 to both sides, so that's x squared equals 7. And then take the square root. So it's x equals plus or minus the square root of 7. So this is negative square root of 7. This is positive square root of 7. And then over here, we need to use the quadratic formula for this one. Okay, so we're looking for greater than or equal to 0, so that's above the x-axis. So these pieces are above the x-axis. So this one's going to be negative. Let me give myself slightly more room. I'll write the answer down here at the bottom. So that's going to be negative infinity, comma, blank, bracket, union, bracket, blank, infinity. So now we can use the quadratic formula. So this is 6 plus or minus the square root of 6 squared, negative 6 squared, minus 4 times 3 times 3, all over 2 times 1. So this is y equals 6 plus or minus the square root of 36 minus 12, which is 24, over 2. So this is y equals 6 plus or minus 2 root 6 over 2. So this is y equals 3 plus or minus the square root of 6. So this would be 3 minus the square root of 6, and this is 3 plus the square root of 6. So that's the idea of how you can use graphs to solve inequalities, which we talked a little bit about in Chapter 2, but now we're talking about it more specifically with these quadratic equations. And we'll continue to use this idea to solve polynomial inequalities and rational inequalities and exponential inequalities and all the things we're going to do for the rest of this class. So the last thing in this section is just a few word problems that we can do now with quadratic equations that are similar to word problems we've done before, but now we can use this idea of maximum. So Mike wants to enclose a rectangular area for his rabbits alongside his large barn using 30 feet of fencing. What dimension will maximize the area fenced if the barn is used for one side of the rectangle? So what we've got is we've got his barn over here, except I spelled it wrong. Barn over here, and then we're going to build a pen. And we're going to use one side of the barn for the barn to make this pen, so we don't need to fence that side. So these three sides together have to add up to 30 feet. So I know that these two sides are the same because it's a rectangle, so let's call those X. And so then what I have left over is my 30 feet minus the 2 I already did. So this last side is 30 minus 2X. And then what we're looking for is area, and area equals length times width. So area would equal 30 minus 2X times X, which is 30X minus 2X squared. And now what we want to do is we want to maximize the area. So that means to maximize the area, we want to find the vertex. Okay? So one way you could try and do that is with your graphing calculator. So we could graph 30x minus 2x squared. Okay? And if we zoom out and come up here to the top, we should be able to get what the vertex is. So that's 7.5, comma 112.5. So the vertex is at 7.5, comma 112.5. And so this is my X, and this is my A. So the dimensions of 7.5 feet by, now I know what X is, so now I need to plug that into this to figure out my other dimension. So my other dimension is 7.5 times 2 is 15. 30 minus 15 is 15. So 7.5 feet by 15 feet will give us a maximum area of 112.5 feet squared. So that's what this ordered pair tells us, and then this is the answer they're looking for, the dimensions that maximize the area. So that's the idea. So that's one example. So one example is maximizing area. Another example we could use is maximizing profits. So Mona Collini gives a walking tour of Honolulu to one person for $49. To increase her business, she advertised at the National Orthodontist Convention that she would lower the price $1 per person for each additional person up to 49 people. What is the maximum revenue for her tour? So revenue simply means total amount of money she makes on the tour. So the idea here is if we have the number of people and let's call that lowercase n, and then we have the cost per person. Okay? So if I have one person, the cost is $49. If I have two people, the cost is $48. If I have three people, the cost is $47. If I have four people, the cost would be $46. And for each additional person, the cost goes down by $1. So if I have n people, how can I figure out the cost per person? Well, if you take for example, I could take a number minus this n and get this number. Well, the number minus n that gives me the cost per person is 50. Because if I take 50 minus 1, I get 49. 50 minus 2 is 48. 50 minus 3 is 47. Then revenue is equal to the number of people, so n, times the cost per person. So the equation here, R, would equal n times 50 minus n. So R is 50n minus n squared. And so we could find the answer to this problem the same way we did the one above. We could graph that. So if I graph this one, it's 50x minus x squared. And I need to come up here to the top of my graph, to the vertex, and I get 25, 625. So this one is 25, 625. So in this case, this is N, and this is R. So 25 people would max the revenue at $625. And so in this case, this is the answer we're looking for, the maximum revenue. Okay, and then the last one here, we'll just go ahead and do together, and then we'll be done with this video lecture. So if you want to pause, you can, and then try this one first, and then we'll go over it. But I'm just going to go ahead and walk through it now. So Chandra wants to enclose a rectangular garden with 200 feet of fencing. What dimensions for the garden will maximize the area? So we've got a rectangle. Okay, so if I know these two sides are X, then the other two sides have the rest of the fencing between them. So that would be 200 minus the 2x, but then I have to split it in two, so I'm going to divide that by 2. So that's 100 minus x. So these... And then area is length times width, so that's x times... not 8. X times 100 minus x, so that's 100x minus x squared. And so once again, we can solve it by graphing. So put in your equation. So 100x minus x squared. And once again, we just have to go up until we get to the top of this graph here. And in this case, it's 50, 2500. So the vertex in this case is at 50, 2500. So this is the x and this is the area. So dimensions of 50 yards by 50 yards would max the area at 2,500 yards squared, or squared yards. Okay, so yeah, so that's it for 3.1. So that's the end of this lecture video. As always, if you have questions about anything in this section or anything else for the class, feel free to email me, call me, or text me. That information is in the emails you're getting from me. And that's it.